Hello, I'm Professor John Kelly, and this is the Weber Auto YouTube channel. Today we are going to prepare to remove the high voltage battery from our 2021 Ford Mustang Mach-E GT version. And part of that removal procedure involves depowering the high voltage system on this car. And what that means is we want to make sure that there is no high voltage on any of the high voltage cables attached to the battery housing. So I showed you in a previous video on the high voltage components on this car that there are several electrical connectors at the battery front of the battery and a connector at the rear of the battery for the rear inverter and motor. And we want to make sure there is no high voltage on those cables before we get down there and start unplugging things and undoing bolts and coolant lines and everything to remove the battery. So there are two ways to depower the high voltage system on this Mustang. One way involves using the factory Ford scan tool, the Ford Diagnostic and Repair System software called FDRS, and also using an interface module like this one right here called the VCM II, the Vehicle Communication Module version 2. There's a version 3 that I've had on order for, oh my word, 9 months. And because of the chip shortage, I still haven't received it. The version 3 has some faster communication capabilities with the vehicle and is required on some vehicles, but on this Mustang, the VCM II seems to be working just fine. But anyway, we have, through a laptop computer I have over here, connected through this VCM II to the data link connector under the dash of this Mustang. We can command the high voltage contactors inside the battery to open, and then the scan tool will verify that the voltages outside of the battery connected to all of these other high voltage components that we looked at in my previous video. It'll verify that the high voltage is no longer there without even getting a multimeter out, without having to do any high voltage checks, without having to wear any personal protective equipment. So that's a nice automated procedure. I've done it in my classes several times. I really like it. It works well. But if you don't have the luxury of having a Ford scan tool, there is a manual disconnect method also. Okay, so let's use the Ford Diagnostic and Repair System automated procedure for depowering the high voltage system. I'm going to start the FDRS software. I've already turned on the vehicle to the accessory mode, and that's when you do not step on the brake pedal, but you do hit the power button one time. We have to tell it that we're connecting through our VCM II communication module. We've worked on this car before, so it's saved the VIN number and the configuration. So I'll hit go, and now the software will communicate with Ford servers to see if there's any updates for any of the modules. It'll check all of the onboard modules on the car for diagnostic trouble codes and let us know if there's anything that needs to be diagnosed, if there's any problems on the vehicle. All right, the software has finished communicating with the car and the server. It has checked for diagnostic trouble codes on the vehicle. There's only one module that shows diagnostic trouble codes present. And if I click on that, there it is right here, the boot trunk lamps. The front trunk lamp does not illuminate, and that's because it's removed. I've taken the compartment out. It's behind me on the shelf over there. There's a great big luggage compartment that goes under the front hood here. All right, so now we are going to go to the toolbox, and there is a test. There's a big long line or list of tests here. You can save favorites. So in my favorites, I have saved the battery energy control module high voltage system de-energizing. Ford service manual calls it depowering. So de-energizing, depowering. I'm going to click run on that one. All right. Tells us that this tool is restricted to qualified personnel, and there's various requirements for what that means. You need to have some training if you're going to be going in and removing any high voltage components. The majority of that type of work requires some sort of a depowering procedure. So let's continue. Ignition switch in the accessory mode, it already is. Prevent the risk of high voltage shock. Always follow the service information instructions for depowering the system. Follow all the safety warnings in section 100-0 of their service manual, all their high voltage safety warnings. Failure to follow instructions may result in personal injury. All right, so now they're going to check for diagnostic trouble codes that might indicate that this depowering procedure won't be able to complete successfully. So the vehicle should be in park. The external charger should be disconnected from the vehicle charging port, which it is disconnected. So we'll hit continue. Now it's going to read trouble codes. And if there were any trouble codes, they would show up here in this table, but there are none, and that's a good thing. So this checks for loss of isolation trouble codes. Loss of high voltage isolation, right? Then it gives us our high voltage isolation resistance. By law, it needs to be at least 500 ohms per volt, and we have a almost 400 volt battery, so we need at least 200,000 ohms of resistance between the high voltage positive cable and the vehicle chassis and the high voltage negative cable and the vehicle chassis. And we are reading 1,301.9 kilo ohms, so roughly 6 times the minimum required by law. So that's good. And this green bar here, the bar graph, if it were red, that indicates a problem. So we'll hit accept. Yeah, that's fine. Now it's going to check for codes related to contactors being stuck shut. And as I mentioned in my first video on the Mustang on the high voltage components, the contactors are these switches. There's one for the positive cable, there's one for the negative cable, and there's more, but basically there are 2 contactors. And what they do is they connect the actual high voltage battery inside of the housing to all of the high voltage components, the orange cables outside of the battery. And if those contactors are stuck shut, they will set a trouble code. All right, so let's continue on. There are no trouble codes for stuck shut contactors. So now what we are looking at here is the FDRS software is looking at our high voltage battery voltage. Currently, it is at 379.9 volts, as you can see, which gives us a green bar graph. So right below that, it shows us that our voltage at the inverters is the same, 379 volts. Right below that, it shows us that our voltage at our high voltage air conditioning compressor is 380. At the DC to DC converters, 378. And at our onboard charger module is 379, which is exactly what we would expect, because right now, the scan tool has closed both sets of contactors, or both contactors, the positive contactor for the positive side of our high voltage battery and the negative contactor for the negative side. And we would expect all of the high voltage components that I showed you in the previous video to have battery voltage to them. So now the next step is we are going to disable the system, and then it'll come back in and check those voltages again. And we're going to expect all of them to drop down to a safe voltage below 60 volts, except for the battery voltage itself. So I'm going to hit accept to continue. So now we have to turn the vehicle off. Okay, I just turned the vehicle off. So now here's the very important part of this procedure. The scan tool software says follow the high voltage battery disconnect and connect workshop manual procedure in section 414-03 high voltage battery mounting cables to correctly activate the service disconnection. So the service disconnection, As I mentioned in the previous video on the high voltage components, underneath the hood here is this green low voltage service disconnect connector. And this connector has two wires going to it. Those wires, as you can see in the schematic, provide power to the contactors inside the battery. So opening this circuit will remove the power from the contactors. And what I mean by power to the contactors is the contactors are controlled by the 12 volt system on this car. So our 12 volt battery, our 12 volt charging system, the DC to DC converter and all of that is there so that when you get in the vehicle and step on the brake and hit the power button, it is going to use the 12 volt power to close those contactors to provide power, high voltage power, on those orange cables going to all those high voltage components that we saw in the previous video. So before we open that circuit, if you look real close, right down at the bottom here is the word on. So when this connector is plugged in or pushed down all the way, the circuit is on, which means the contactors will have power to be able to activate and deactivate. But we need to depower. We're going to deactivate that system. So there's a red connector position assurance clip right there. I'm going to lift up on that. And then there's a green tab, but you would push in on this green tab and then lift up. And notice now that I've lifted up, we have the word off right there. That means the low voltage power to the contactors to allow them to close when commanded to close has been removed. Notice that we have a hole right here, and the purpose of that hole is to put a do not operate tag on there. OSHA requirement 1910.147 for Lockout-Tagout requirements requires that we come in with some sort of a do not operate tag, preferably on a padlock. But in my classes, I'm not going to use the padlock. I'm going to use this carabiner or a zip tie. And we are going to put this carabiner right through that hole, and that will prevent unintended reconnection, whether it falls down with gravity, the pull of gravity, or if somebody else comes along and just pushes on it just because it's there. This will prevent that. The padlock would prevent anyone from doing that, which is the OSHA requirement in a live work environment. Here in this education environment, we're using the carabiner instead. Okay, so now we have opened the low voltage control circuit to the contactors, and they cannot close. So now we'll go back to our software and hit continue. Now it says, for safety reasons, please wait 5 minutes for any residual high voltage in the system to be depleted. So in the front inverter and the rear inverter on this all-wheel drive vehicle, and it's already been several minutes, but the software forces 5 more minutes from the time that you open that up for these capacitors to go through what's called a passive discharge, where they discharge on their own. There's a resistor put in parallel with the capacitor that discharges it every time the contactors open. And so we have to wait. So we'll wait the 5 minutes, and then we will continue with the scan tool procedure. Okay, as you can see now on the scan tool, we still have our high voltage battery voltage inside the housing at 380 volts. But our inverter voltage is down to 11.3, air conditioning compressor down to 12, DC to DC converter down to 0, and our onboard charger connection at 0.6 volts. This has verified that the contactors are open, and now you can go down and unplug the high voltage electrical connectors on the battery. Okay, so we will hit accept to continue. Turn the ignition off. We'll hit continue again. High voltage system is de-energized. Remove the key fob from the vehicle. Application is finished. Press OK to continue. So we have just completed, without touching a multimeter, without putting on high voltage personal protective equipment, we've completed the high voltage depowering on this vehicle. Now that is the automated method. So the manual high voltage depowering procedure, if you don't have a factory scan tool or a scan tool with that function, is to turn the vehicle off, come to our low voltage service disconnect lever and unplug it, just like we did here, and put a lockout in it. Wait the 5 minutes for the inverters, the capacitors in the inverters to go through a passive discharge, and then put on high voltage personal protective gloves and the leather outer protectors and all your other personal protective equipment. Grab a category 3 multimeter that has been verified as working properly, and get down there and unplug the inverter connection at the front of the battery. And when you unplug that, you're going to check the voltage at the 2 terminals of the battery and make sure that it's down to less than 60 volts, but it should be 0. You're also going to check the harness voltage side going up to the inverter with the capacitor, and it should also be discharged down to 0. So if it checks 0 at the 2 terminals coming out of the battery, then the contactors are open. But there are 2 sets of contactors in this battery. There's another set for the DC fast charge connectors. So you have to do the same thing on every electrical connector. You unplug it, you check the voltage to make sure that it's at a safe level, and then continue. And once you've verified that, then the system is disabled. General Motors, in their new the Cadillac Lyriq and the GMC Hummer, and I'm betting all of the other vehicles that they, electric vehicles they're releasing, use this exact same green connector. It's made by Yazaki, a supplier. That connector I've seen in the GM training on the Lyriq and the GMC Hummer. It's a pretty slick way to go. It's very similar to the cut loops that you see under Teslas that depower the contactors. Some of these also depower the restraint systems, the airbag systems, at the same time. So if you have 4 wires going through there, chances are it does the contactors and the restraint system. Ford, I've looked in their service information, and for the Ford Lightning, for the Ford E-Transit van, for the Ford Escape, for the Ford Maverick truck, they all use this exact same low voltage service disconnect. Now, General Motors calls it a high voltage service lockout. I'm not sure which name I like better, the low voltage service disconnect or the high voltage service lockout, because this is a low voltage circuit. The cable going to it, it's just a 12 volt circuit. The high voltage service lockout is a good name also, but it kind of implies that it's a high voltage circuit, and it's not. And by the way, by law, the cables, only the orange cables have to be orange, or only the high voltage cables have to be orange. The electrical connectors do not. But most high voltage electrical connectors are orange anyway. I had several people ask me about that, but it's not required that they be orange. So vehicles with this low voltage service disconnect or high voltage service lockout or cut loops or whatever it may be, most of those do not use the old manual service disconnect lever, MSD, or as Toyota called it, a service plug grip. They don't use these. This battery does not have a manual service disconnect lever, and I have 4 different ones right here. I've got a whole drawer full of various ones, and on previous hybrid and electric vehicles, you would go find where this is and unplug it. You don't do that on these. This kills the power to the contactors, and unless the contactors will themselves shut, then this contactor should go open when you open that circuit. All right, well, we have successfully depowered this Mustang, and in the next video we're going to actually remove the battery and look at the contactors and the other parts inside of it. Thanks for watching, and have a good day.